In the previous video, we showed you the three forms where you can use trigonometric substitution. This time, we're going to work at this particular problem, okay? The integral of 4 minus x squared dx. So our goal is to remove the radical sign, and this is of the form a squared minus u squared. By the way, how do you know what is a and what is u? You recall that u is always a function, and a is a constant. So this is a constant, this is a function, so that is the a squared minus u squared form, and I'm going to use sine. If this is my u, this must be my u, this must be my a. Now, how do I know this is my a again? Well, that is my hypotenuse. The longest side is always subtracted from. And so by Pythagorean theorem, the third side should be a squared minus u squared. And I'm going to use here sine. Sine of theta is equal to u over a, or u is equal to a sine of theta. So in this case, my a is 2 and my u is x. So my x will be represented as 2 sine theta. So looking back at our original problem here, it's the square root of 4 minus x squared. What is our goal? We will replace this by some function, trigonometric function without the radical. And here's what we're gonna do. We're gonna replace actually that 4 minus x squared using this substitution right here. If x is 2 sine theta, then I'm gonna get 2 sine theta squared. And what will this give me? That will give me 4 minus 4 sine squared theta, and that will give me 4 times 1 minus sine squared theta, and from your Pythagorean identities, 1 minus sine squared is cosine squared theta, and so that reduces to 2 cosine theta. Okay, in the previous video, we showed you how we changed the square root of 4 minus x squared to an expression without the radical sign, and that simply became 2 cosine theta. In this segment, we are now going to replace the x by also a trigonometric function. Knowing that our x is 2 sine theta, then our dx is 2 cosine theta d theta. Putting the two together, we will now have everything in terms of theta. So the dx is 2 cosine theta d theta, while the 4 minus x squared, square root of 4 minus x squared is 2 cosine theta. So now the integral simplifies to 4 cosine squared theta d theta. We can now pull out that 4. And so we will now use the reduction formula. Cosine squared theta is the same as cosine 2 theta plus 1 over 2 d theta. Now we can integrate our function here. You notice that from power 2, our trigonometric function simply became linear. That's why it's called reduction formula. There are two of those, okay? Cosine squared theta, let me recall that here, is equal to 1 plus cosine 2 theta over 2. And the other one is sine squared theta, which is 1 minus cosine 2 theta over 2. So whenever you see even powers of cosine and sine by themselves, just like this, that's the time to use those reduction formulas. So continuing our problem here, the integral now becomes 2 times cosine 2 theta plus 1 d theta. And the integral of cosine 2 theta is sine 2 theta. Now you notice that your u has a constant there. So we actually are doing here implicitly u substitution. If u is 2 theta, then du is 2 d theta. And so we will need to bring out that 2 again. So d theta is equal to du over 2. And so that 1/2, okay, that 1/2 will now be here for sine 2 theta, okay, plus, now don't forget there's a 2 there, okay, the integral of 1 is theta plus c. So simplifying this, we get sine 2 theta plus 2 theta plus c. But we recall that our problem is in terms of x. So what we will do now is replace everything in terms of x using precisely the same triangle here, okay? So let me draw my triangle over here. Okay, so that's how we began this problem. We are going to draw now our triangle so that we can rewrite our answer, which was sine 2 theta plus 2 theta plus c in terms of x. Okay, this was our answer earlier. So what we will do is replace sine 2 theta by trigonometric identity 2 sine theta cosine theta. Okay, and we have to rewrite theta in terms of arcsine or arccosine or arctangent. There are many ways to write theta, and I'm going to explain that in a moment. So for the time being, we will say 2 theta plus c, and let's draw our triangle, okay? That was our original triangle. Now we will draw our triangle in terms of x, okay? So here we go. We have a sine theta is equal to u, or 2 sine theta is equal to x, okay? So we can rewrite this as sine theta, okay, is equal to x over 2. So putting our theta here, this is gonna be x, opposite, over hypotenuse, Pythagorean theorem, 4 minus x squared. So there you go. We have sine theta is equal to 2 times x over 2. Cosine theta is the square root of 4 minus x squared over 2. I'm simply using the definition of trigonometric functions, and we will replace theta by either arcsine, x over 2, or we can use arccosine, the square root of 4 minus x squared over 2, or I can use arctangent and say x over the square root of 4 minus x squared. So this particular part, this theta right here, can be done in 6 ways, okay? Sine, arcsine, arccosine, arcotangent are simply 3 different ways of expressing the same theta here, okay? Plus c, plus c, plus c. Simplifying everything, we should now get 1/2 x square root of 4 minus x squared plus, if we use the arcsine, then we will get 2 arcsine x over 2 plus c. And you know that this can be written in 6 different ways. That's our answer.